we're going to talk a little bit about polar coordinates and rectangular coordinates. So this is a topic that comes up in APBC calculus, but it also comes up in honors pre-calculus, which is the first time you'll see it. So what we're going to do in this video is talk about relating polar coordinates, r comma theta, to rectangular coordinates, x comma y. So we need two things to do this, and we learned both of them in basic geometry, or maybe in your Algebra 1 class, depending on what your teacher covered, also maybe in Algebra 2. So the two things that we need to relate these quantities, r comma theta and x comma y, are Pythagorean Theorem and SOHCAHTOA. So most of us feel pretty comfortable with those things, hopefully. So let's start with the Pythagorean Theorem. So if we look at this, I put a dot on my plane that is both x comma y if written in rectangular coordinates, meaning is it x units in one direction horizontally from the origin, and it is y units up, right, from the x-axis, right? So x comma y. But that same point could be written as r comma theta, where I turn from the positive x-axis, which is called the polar axis, I turn counterclockwise up to some designated spot that we call theta, and then I walk r units from the origin, aka the pole, out to this spot. So this r comma theta written in red is the same spot as x comma y. They're just written in different ways. So this is sort of like me giving you street directions, walk x blocks east and y blocks north, versus this r comma theta that says, hey, just go ahead and turn theta degrees and then go directly r units this way. So same spot. So now let's look at this right triangle that's created. So using Pythagorean theorem, I realized that x squared plus y squared should give me r squared, because x and y are the legs and r is the hypotenuse. So the first equation we can get to relate these is x squared plus y squared equals r squared, right? So if I wanted to find the r of a polar coordinate, I could do x squared plus y squared, and I'd get r squared. The second thing that I know is that using SOHCAHTOA, I can find a relationship. So I'm now going to write three more equations using SOHCAHTOA. I'm going to find a relationship between x and r and theta, and y and r and theta, and also between x and y and theta. So using SO, right, sine is opposite over hypotenuse, I get that the sine of theta is y on top of r, which means the equation you'll usually see is that y is r sine of theta. So if I have a polar coordinate and I really want to find the y coordinate that would go with it, I could do it by doing r sine of theta. My next formula, number 3, is going to be ka, which would be the cosine of theta, is the adjacent, which would be the x, over the hypotenuse, which is the r. So the equation you'll generally see is that x is r cosine theta. And that kind of jives with what we know about x and y in general. Y is usually, like on a unit circle, y is sine, and so it kind of makes sense that it matches sine. And then the fourth equation I can use is TOA, which is that the tangent of theta is the opposite, y, on top of the x. So sometimes you'll see this as theta is the arctangent, or inverse tangent of y on top of x, because this is usually a way for you to find theta. So the four equations that we need to relate to relate polar to rectangular, rather, are Pythagorean theorem, right? X squared plus y squared equals r squared. So, as in sine equals opposite over hypotenuse. Ka, as in cosine equals adjacent over hypotenuse. And TOA, as in tangent equals opposite over adjacent.